Deltech Chemistry 100 and Chemistry 110, Unit 1, Chemistry and Measurements, Introduction to the Scientific Method. Today we're going to cover some key terms, definitions of chemistry itself, matter, significant figures, also known as significant digits or sig figs for short, conversion factors, which are part of a concept known as dimensional analysis. We'll talk about terms associated with the scientific method, terms like hypothesis, law, and theory, and we'll talk about the differences between accuracy and precision. Many of these words are used in the same way in everyday colloquial English, such as hypothesis and theory, or accuracy and precision, but in science, these names mean something very different. So we'll talk about the scientific method. In another unit, we'll talk about scientific notation, accuracy and precision, units of measurement and the metric system. We'll talk about measured numbers and sig figs. We'll talk about sig figs in calculations and how to round them properly. We'll talk about both the metric system and the international system known as the SI system, which is closely related to the metric system. We'll talk about conversion factors and how they're used in dimensional analysis. And we'll talk about how density is calculated based on mass and volume and the definition of specific gravity. So, let's talk about some definitions. Theory. Theory is a well-established hypothesis. We have the theory of natural selection, the Big Bang theory, cell theory. These are all theories to a scientist, and what we mean by theory as a scientist is that these were ideas that were postulated for how something happens, and these ideas were tested over and over again, sometimes thousands or even tens of thousands of times in different experiments, and every experiment supported this original hypothesis, so we now call it a theory. We don't tend to prove theories correct. We usually do experiments that either disprove the theory or support the theory, but there's no proving the theory. We also have a concept called a law in science. A law is a concise scientific statement of fact. It's frequently mathematical in nature. So we have the law of mass energy equivalence, which you know of as Einstein's theory of relativity. E equals mc squared is part of that. We have Dalton's law of partial pressures, which is a law that you will learn in the gas section in Unit 6. And we have Newton's second law, which is one of the fundamental bases of modern physics. This is a law that states that force is equal to the mass of an object times its acceleration. Matter is defined as anything that has mass and a volume, or anything that has mass and takes up space. So what is mass? Mass is a measure of how much matter you actually have. For example, if we have a human on Earth that has a certain amount of mass, say they have a mass of 70 kilograms, if you took them to the moon, their weight would be very different, but their mass would remain exactly the same because they have the same amount of stuff, of matter in that object, in their body, whether they're on Earth or whether they're on the moon. And chemistry is the study of matter, how it undergoes changes, and the energy that accompanies these changes. In most chemical reactions, either energy is produced by that reaction or energy is actually absorbed by that reaction. And you can tell the difference very easily. If the reaction gets hot, it's producing energy. If it feels cold because it's absorbing heat from its surroundings. And that would be a reaction that absorbs heat energy during its process. So the scientific method is a multi-step pathway, and this is just the general pathway. It can be done in practice in a number of different ways, but this is one way to look at it. We start with observations. You notice something about the world around you, about the nature around you, and once you notice these things, you begin to ask questions. How does this work? What makes this go? Why does this do this? And that will lead you to make a guess about why these things work. Your guess may be right, your guess may be wrong, it may be completely wrong, it may be only a little bit wrong, but it has to be a testable guess, and we call these a hypothesis or hypotheses for plural. So it must be testable. Why is it testable? Well, if you come up with a hypothesis that says a magic creature in the sky has made this disappear, and that's why it disappears, or a magical elf moves this water from here to here, and that's the reason, well, that's not particularly testable. We can't make a test that proves or disproves that, or at least we can't make a test that disproves it or supports it. So you have to make a hypothesis, a guess that can be tested. And once you make that guess that can be tested, hey, I think that this is due to natural forces that are pulling this rock towards the earth. Or I believe that wind pressure, air pressure is pushing this object from here to here. Those are hypotheses that are testable. And then you design a test that tests the hypothesis. And you have to ask yourself, what would prove my hypothesis wrong? What result would I get that would say my hypothesis was wrong? So then you do your experiment and you look at your results and you ask yourself, does the result disprove my hypothesis or does it support it? We don't tend to say that it proves it because you can't really prove a hypothesis. You can't really prove a theory. You can only disprove it or support it. And once you do the experiment and you decide whether it disproves or supports it, we do further analysis and we ask the question, does the hypothesis need to be modified? Is it good the way it is? Do we need to tweak it a little bit? Or is it completely wrong and we have to start all over again? Well, if it's completely wrong and we have to start all over again, we look back at observations and we go through the same cycle again. And if it has been tested and each test supports our hypothesis, we then call that a theory or a scientific theory. So the way we use the word theory in science is very different than the way we use theory in everyday English. Theory in science means this is an idea about how something works that has been tested so many times in so many ways, and it's never been disproven. And that is what we call a theory. So we have a lot of theories in science that are considered the true explanation until somebody comes up with a better one. Things like natural selection as a mechanism for evolution, or cell theory, or also known as cellular theory, for a mechanism about how cells work in organisms, living organisms.